So you can see here, okay, you can see here ice, okay, ice crystals can be converted to liquid. Liquid can be converted to again ice. Understand? So the original substance again getting back, again coming back. Okay, okay. When we change the conditions of temperature, so this ice is again going back to its original state. Okay, that state. So that is called what? Reversible change. Okay, that is called a reversible change. And irreversible change means what? Irreversible change. So an irreversible change is a change that takes place in such a way that the original situation cannot be restored even after the conditions are altered. Okay, even after the conditions are changing, then it will not restored. Okay, suppose for example here milk can be changed into curd. Curd never come back to original substance. Okay, milk. Okay, curd never come back to original substance. Means milk. Okay, so that is called a irreversible change. Irreversible, reversible, and irreversible change. So next to change, physical and chemical changes, very, very important changes, physical and chemical changes. So as we go to higher classes, we will be dealing with physical and chemical changes in our study of chemistry. So now physical change, basic definition we shall discuss in this one, basic definition. Here a physical change is a change which can be reversed by reversing the conditions and in which no new matter is formed, no new substance is formed. Okay, a physical change, it is a type of change in which no new substance is formed, and so that change will be go back to its original substance when you alter the conditions of temperature. Okay, when you reversing the conditions of temperature and pressure, so that substance will be going back to original substance. Okay, and there is no new substance in a physical change. That is called a physical change. Okay, chemical change means what? Okay, if a particular substance is converting into another substance, then if you reverse the conditions, then the substance will not be going back to original substance. It means there is a new substance always. That is called a chemical change.
Hi friends, welcome to my cooking show. Just kidding. Welcome to Manocha Academy, and this video is going to be about physical and chemical changes. I'm going to do some things here on my kitchen table, and you need to be a science detective and identify the physical and chemical changes that you see here. And then we'll finish off with our top 3 exam-oriented questions on this topic. Before we start, let's do a quick recap on physical and chemical changes. In a physical change, no new substance is formed and it's reversible. But in a
Here in a physical change, okay,
chemical change, a new substance is formed and it's irreversible. So the two important questions to ask yourself
in a
when
chemical change,
deciding the
no new
type of
substance is
change
formed.
are,
In a chemical change, there is a
is
new
a new
substance
substance
always.
formed? Is it irreversible? If the answer to both of these questions is yes, then it's a chemical change. Otherwise, it's a physical change. So watch carefully the things I'm doing here and you try to classify them as a physical change or a chemical change. So are you ready? Let's start. I'll start by lighting this candle here. Now I'm going to make some lemonade. I'll show you my recipe. Hopefully it turns out good. So first cut the lemon. I need powdered sugar. So I'm going to crush this raw sugar in the grinder here. Then mix the powdered sugar and water. Stir it so that the sugar dissolves nicely in the water. Now squeeze some lemon and add a pinch of salt. Let's drop in some ice cubes. I'll wait for the ice cubes to melt so that the lemonade becomes cool. Now let me enjoy the lemonade. It's perfect and refreshing. The candle is still burning. Can you see the wax that has melted here? Are you ready with your answers? In all the changes you saw, these are the chemical changes. In these changes, some new substances are formed. And here are the physical changes.
So here, all these are physical changes. Cutting of lemon is a physical change. Actually, there is no new substance is forming when you cut a lemon. Or grinding of sugar is also a physical change because there is no new substance. One substance, okay, a solid substance is converting into a powdery substance only, okay, okay, because state is changing only, state, okay, but there is no change in its composition. So that is why it is a physical change only. Grinding of sugar and cutting of lemon is also physical change, and dissolving of sugar is also physical change because it is not mixing. It is not mixing chemically. Okay, it is mixing, but it is not mixing chemically. Just physically only they are mixing together. Such a type of changes are called physical changes. But melting of wax, okay, because some amount of wax is evaporating, so it means it is a chemical change. Understand? And
These changes,
digestion of lemonade is also a chemical change because when you drink a lemonade or lemon juice, okay, that will enter into our stomach, and there are some chemical reactions will be taken place inside of our stomach. So it is a chemical change. And also here, mixing lemon, salt and water, it is also a physical change. Melting of ice, okay, because he put some ice cubes in water, that lemonade, and that is also physical change because it is not mixing chemically that particles. And here melting of wax is actually it is a physical change, okay, but burning of wax is chemical change. Melting, okay, melting here, burning of candle is a chemical change, but melting of ice or wax is physical change.
no new substances are formed. A burning candle is an interesting example where both physical and chemical changes are taking place.
Okay, both changes are there,
The
physical
physical
and
change
chemical changes.
is the melting of the wax, and the chemical change is the burning of the candle. Now that we've looked at the examples of physical and chemical changes, let's look more closely at the differences between the two. For physical change, we'll use the simple example of melting of ice. And for chemical change, we'll use the example of burning of a candle. The first difference is that in physical change, no new substances are formed.
Okay, in a
So for
physical
example,
change, no new substances are formed. In a physical change, actually, no new substances are formed. Such a type of changes are called physical changes. And in a chemical change, there is always a new substance is formed. That is called a chemical change. Okay.
when ice melts, you get water. It may look different, but chemically it's the same. It's H2O. If we try to represent the melting with a reaction, it would look like this. As you can see, it's water, H2O on both sides.
Yes.
Only the state.
When water is present in solid form, it means ice are in the form of water. So the formula is same, H2O, H2O only. Okay, the formula is not changing. Whether it is in solid form or it is in liquid form, the formula of water is what? H2O only. So there is no change in its chemical formula. Hence, it is a physical change, not chemical change. Okay. If chemical composition is changing totally, then it is a chemical change. If chemical composition or if physical composition is only changing, then it is called physical change. Okay.
State is changing from solid to liquid. In chemical changes, new substances are formed. So in the burning of the candle, what are the new substances that are produced? The candle is a hydrocarbon, and on burning, it gives out carbon dioxide and water vapor. Of course, we can't see that because they are colorless gases. Here is the simple unbalanced equation for burning of a candle. As you can see in the equation, the
Burning
hydrocarbon
of
is
candle is
combining
actually
with
a
oxygen
chemical change because
and
this candle, okay, CXHY means formula, okay, because it does not have a particular formula, so it represents CXHY only, okay. The number of carbons and number of hydrogen, there is no particular number, so just it is mentioned with CXHY, plus it is combined with oxygen to give carbon dioxide and water. Vapor will be formed here, okay, when candle is burning. Hence, it is a chemical change. Okay, new substances are forming in this reaction. That are what? Carbon dioxide and water. That is why it is a chemical change.
producing carbon dioxide and water vapor. The second difference is that physical changes are reversible. They are temporary. For example, the melting of ice is temporary. We can easily reverse it by refreezing the water back. Chemical changes, on the other hand, are irreversible. They are permanent. For example, the burning of candle is a permanent change because once the candle is burnt, there's no way we can get it back. Let's add these two important differences between physical and chemical changes on our.
Here, no new substances or new substances are formed. Chemical changes. Okay, new substances are formed in this reaction, in this change, and it is irreversible. Irreversible. Okay, the once the product is formed, then we cannot reverse the condition. Okay, we cannot reverse the product to original substance. That is called chemical change. Then physical change means what? There is no new substances are formed. No new substances. Okay. Only one type of matter is converting into another type of matter. Only physical state is changing, varying. And it is reversible also. Okay. When ice melts to water, then water can be converted to ice again. That is called what? Physical change. Okay.
Concept board. The third difference is regarding mass. In a physical change, the mass of the substance remains the same. But in a chemical change, the mass of the substance generally changes. Let's go ahead and verify this with the help of a simple experiment. In this experiment, Let's measure the mass of the ice cubes before and after melting. First, let's measure the mass of the ice cubes. As you can see, it's 33 grams. Now I'm going to let the ice melt. After all the ice has melted to water, as you can see, the mass is still 33 grams. So in a physical change, the mass remains same. In a chemical change, the mass of the substance generally changes. Let's verify this with a simple experiment. For the experiment, I'm going to use this new candle and we are going to measure its mass before burning it and after burning the candle. I'm using this small candle because otherwise it's going to take a long time to burn. So first, let's measure the mass of the unburnt candle. The mass of the unburnt candle is 10 grams. Now I'm going to light the candle. Now let's measure its mass after burning. We are left with only 3 grams of the candle. So the mass of the candle has reduced by 7 grams. But doesn't this violate the law of conservation of mass? The law of conservation of mass states that matter can neither be created nor destroyed. So the mass should remain constant even for a chemical change. But in this case, we saw that the mass of the candle is decreasing. So how can you explain that? Well, the reason is we've been only looking at the mass of the candle. We haven't accounted for the gaseous products. Because when a candle burns, carbon dioxide and water vapor are produced. And they are gases. They go off into the atmosphere. And we've not accounted for their mass. So if this experiment is done in a different way, let's say we burn the candle in a closed container like this, then what do you think the reading is going to be? That's right. The mass of the container and the reactants will be the mass of the products and the container. So then the law of conservation of mass is going to be satisfied. The last difference is regarding energy. Now this is the confusing one because you find it expressed in different ways in different textbooks. In both physical and chemical changes, energy may be given out
Okay, students. In that video, we have seen that physical changes and chemical changes. Understand what is the physical change and what is the chemical change. So in one video, I hope you understood more points. I think okay, he explained very well about physical and chemical changes. Physical changes in those changes in which there is no new substance is formed, okay, and that are not that are reversible, actually that are reversible, okay. If you alter the conditions, then the products may be reversed back to original substance, okay. Such changes are called physical changes, and chemical changes means what? Those changes in which there is new substance is formed, okay. Such changes are called chemical changes, and they are irreversible. They are irreversible. So we can see some differences between physical and chemical changes here, okay. A physical change is temporary, actually. A physical change is temporary, okay. It's not a permanent change, and a chemical change is a permanent. So a physical change is a temporary and chemical change is permanent, okay. Physical change physical change is temporary means what? We can uh, reverse back to the original substance by altering the conditions of temperature. Understand? Then a physical change is reversible actually. Okay, it is a reversible change, and a chemical change is irreversible. Okay, chemical change is irreversible, and a physical change is reversible. No new matter is formed after a physical change. Okay, here in physical change, no new matter is formed after a physical change. There is no new substance actually. The same substance will be converted to another substance only. The next changes are exothermic and endothermic changes. Okay, exothermic, endothermic. Exothermic change, a change in which energy in any form is released is called an exothermic change. Okay, actually, exothermic means the change in which heat energy is released. Actually, heat energy is released is called exothermic reaction, exothermic change. Actually, exothermic change. Exo means what? Exothermic heat energy is releasing. Suppose wood is burning. When wood is burning, heat energy will be released. So that is called exothermic reaction. In exothermic reaction, heat energy will be released. Understand here? Okay, exothermic means the change in which heat energy is released. Then endothermic means the change in which heat energy is absorbed. Heat energy is absorbed is called endothermic change. Endothermic, okay? Okay, the chapter is completed. We shall see one more video about physical and chemical changes.
Whatever the day brings, Grammarly helps you communicate smarter, one message.
Today we are learning about physical and chemical changes. Now, a physical change is a change in the size, shape, or state of matter of a substance. The important thing is that in a physical change, no new substance is being created. Take this piece of paper, for example. If you grabbed a pair of scissors and cut the paper in half, well, now the paper would be a different shape, but it's still just paper. You haven't created any new substance, and so cutting is just an example of a physical change. Here's another. No matter what you do to this ball of slime, whether you pull it, push it, twist it, or bend it, it's still just a ball of slime. So pushing, pulling, bending, and twisting are all just examples of physical change. Here's another. If you take an ice cube and put it on a hot pan, you can see it quickly melt into a puddle of water. But even though the puddle looks very different than the ice cube, they're both just types of water. No new substance is being created, and so the melting of an ice cube is just a physical change. In contrast, a chemical change is a change in which one kind of matter changes into a different kind of matter. Say instead of cutting the paper, we decided to take a candle and burn the paper. Well, as you watch the paper burn, what you're seeing happen is a chemical change. A new substance is being created. When you burn paper, the paper is turning into both ash, which you might see on the floor, and the smoke that you see going up in the air. And because paper is turning into these new substances, this is an example of a chemical change. Here's another one you've probably seen before. Fireworks are an example of a chemical change. Fireworks are made by taking an explosive powder like this and lighting it on fire. This turns it into the bright gases and explosions you see in the air. And because the powder is turning into these exploding gases, this is an example of a chemical change. Now here is one more you're definitely familiar with. You can watch as we pour baking soda into a cup of vinegar. Do you see all those bubbles filling the cup? That's a gas or a new substance being created. And because something new is being created, this is an example of a chemical change. Now there's some signs or clues we can look for to tell if a chemical change has taken place. First, you could look for a change in color, like we saw with the fireworks, when the dark powder turned into bright explosions. You can also look to see if the change produced a smell. Another clue is if it releases gas, like we saw happening during that baking soda and vinegar reaction. Finally, you can look for a change in
Here
temperature. And
actually
we're not talking about temperature that
chemical
changes the
changes,
state.
actually there is a change in color and produces a smell, releases gas, change in temperature, not including change in state. Okay, state will be compulsory changing along with the state. So there is a change in color and produces a smell and releases some gases and a change in temperature. These are all signs of chemical changes, signs of chemical changes.
Of matter. We're talking about if you do something and it releases a lot of heat, like an explosion. Let's look at some of these together. Watch as this person cracks an egg into a bowl. Well, which of the following clues for a chemical change do you see happening? Well, the color is not changing, there's no smell released, there's no gas released, and the temperature is not changing. In fact, all that's happening is we're changing the shape and size of the egg. So cracking an egg is an example of a physical change. What about when we put that egg on a pan and start to cook it? Well, what signs of a chemical change do you see happening here? You can see that the color is changing as the egg goes from clear to white. Also, if you were standing in the room, you could probably smell the egg because it's producing a smell. These clues show us that cooking an egg is a chemical change. What about this? Watch as this person swings an axe and cracks this piece of wood in half. What type of change is this? Well, nothing new is being created. The log is just being split into two pieces, and changing the shape or size of something is an example of a physical change. Now here's one more. This is a close-up video of metal rusting. It takes place over several days. What clues do you see happening here? Well, all this person is doing is changing the size and shape of an ice cube. This is a physical change. What about this? What change is happening when you burn wood in a fireplace? Well, you can see that the wood is changing color. It's becoming white and black as it burns. This is also releasing a lot of heat. These are some indicators that this is a chemical change. What about this? When you boil a pot of water on the stove, what type of change is happening? Well, when you boil water, the liquid is turning into a gas. But changing the state of matter is not creating a new substance. A change in the state of matter is just a physical change. And now here's one last one. When I cut this cucumber into thin slices, what type of change is happening? Well, this one was pretty clear. Nothing new is being created. All that's happening is the shape of the cucumber is changing. This is an example of a physical change. So from today, remember, physical changes are changes in size, shape, or the state of matter. But with a physical change, no new substance is created. In contrast, a chemical change is a change where one type of matter changes into a different type of matter.
Our next chapter is water. Okay, in next session we shall discuss about water. In our next session, we shall discuss about water chapter. Okay, this is changes around us. So there are a lot of changes taking place around us. Okay, many chemical changes or physical changes or desirable, undesirable changes. Many changes occurred around us. Okay, knowingly or unknowingly. knowingly or unknowingly, many changes are taken place around us. Okay.
When's the last time you seriously thought about your browser? Does it look like this?
Periodic and non-periodic changes. Periodic changes. Periodic changes are events that repeat themselves after a certain amount of time and whose occurrence can be predicted. The Earth's rotation on its axis, the Earth's revolution around the Sun,
Revolution,
and hence day and night or seasons are examples of
periodic changes, because earth rotation, that earth will be rotated on its own axis always continuously. Okay, so due to that fact, due to that reason, day and night both are forming. Okay, changing. So that is called periodic change. Continue after certain intervals of time. Okay, after certain hours, so that change will be repeated. Okay, that is called a periodic change. Then Earth revolution around the sun. It is also periodic change, because that will be continuously goes on. Okay, then day and night, then seasons. Okay, seasons also periodic change.
periodic change. Non-periodic changes. The changes that do not repeat themselves, intervals of time, natural disasters, volcanic eruptions,
So here earthquake, cyclone, volcanic eruption, these are all non-periodic changes. Earthquake means it will not be repeated. Okay, may or may not, but it is not continuously repeating after certain intervals of time. It is not. It will not. It will never be happen like that. Okay, that is called. That is why it is called a non-periodic change. Okay. Then cyclones is also non-periodic change. Then volcanic eruptions also non-periodic change. Okay, understand periodic and non-periodic. So then changes. Okay, physical and chemical
etc.,
changes.
or some are
Okay, students, I will stop at this time. Okay, I would like to unmute all of you. Students, do you have any doubts? Periodic and non-periodic.
No doubt, sir. No doubt, sir. No doubt. Sir, no doubt.
No doubt.
No doubt. రోహిత్ నేను కార్తికేయ నాయక్ ని ఇస్మాయిల్ రోహిత్ నేను కార్తికేయ నాయక్ ని ఇస్మాయిల్ రోహిత్ నేను కార్తికేయ నాయక్ ని ఇస్మాయిల్ రోహిత్ इस्माइल क्या कर रहे तुम
Students, don't discuss among
क्या
you.
कर रहे तुम इस्माइल
Just discuss with me.
आईआईटी सुनना आईआईटी में है तो मैं
Speak to me, all of you.
अब कहते हो 520
516 आईआईटी बोलो तो चले तो सुना ना
Ashraf,
हाँ नहीं तो
remember physical change.
मैथ्स दो तुम्हारी ऐसे टर्मिनोलॉजी मैथ्स से लिखा नहीं
Ashraf. Mahati, just keep quiet. Mahati,
Sir. Sir.
yes.
Sir, what?
You can ask.
అట్లా కాదు వాళ్ళే దించుకుంటారు 2 రోజులకు ఒకసారి అని అనాలి నోట్లేదు ఏంటట ఏం కొట్టుకోపోయిందట బట్టలు
You can ask me your doubts if you have any doubts.
No doubt. No doubt.
Physical change, periodic, non-periodic changes. Have you heard the video and this lecture?
ఇప్పుడు నెలల 10 రోజులు నెలల 10 రోజులు ఇటే ఉంటుంది 20 రోజులు అని చెప్పాలి
What is the physical change?
తినేటప్పుడు ఆ ఫేస్ లో కూడా ఉంది. తింటున్నావా పంటున్నావా
చమత్తన్నారా మొన్న
అయ్యో 50 గోవింద గోవింద నమ్మింది
Okay, students. Bye. We shall meet in next.